So a particle is moving along the curve given by the equation this. As the particle passes through the point 4, 20, its x coordinate is increasing at a rate of 4 units per second. We need to find the rate at which y coordinate changes. So first see what is given. We are given a function and we are given x equals 4, you can see here, y equals 20, and then that coordinate x increases at a rate of 4, that means dx dt is 4. What is our goal? Find the rate at which y coordinate changes, that means you want to find dy dt. So for simplicity, I take square both sides just to avoid the radical sign. If you square both sides, you get y squared equals 16 here, and then radical is removed like this. Further simplify, you get this. You can use implicit derivative to find dy dt. We take derivative of y with respect to t, so y squared will give you 2y, and then dy dt equals, this is 48 is a constant, derivative of x will be dx dt. And then plug all the values you have here and solve for dy dt. You are done. Now the same question I bring here, but with a little more complicated situation. The particle is moving along the curve given by this equation. As the particle passes through the point these, its x coordinate is increasing at a rate of 4 units per second. Find the rate of change of distance of the particle to the origin at this instant. We are not looking for dy dt, we are looking for distance from the origin, how it is changing. So again, look at given information, y equals given, that's the function. What else we have? X equals 4 and dx dt is 4 from here. X is 4 and dx dt is 4. So when you replace x equals 4 in these and solve for y, you get y equals 20. Now let us take a point xy on the given graph, and I show you the graph. If you use your calculator, your graph look like this for this function. Now is a point here, this point is moving along the graph, so we want to see how the distance changes from the origin. So this distance, yeah, so we know the distance from origin will be, this is f, so f square will be x square plus y square. You understand the distance between 2 points, and we square it just to remove the radical sign. Next, see the goal, we need to find df dt, how distance changes. Take the derivative. So first I replace my y from here. So y squared will be 16, 3x plus 13, just to make it one variable, or you can use implicit derivative. Now derivative of f square will be 2f, then df dt, then x square is 2x dx dt plus 48 dx dt. And also I need to know what is f. So the point I have 420, if you take the distance between 0 to 420, you get f, which is 4 radical 26. Now we need to plug all these values here. So first x is 4, and then dx dt is 4 plus 48 dx dt is 4. Now replace your f by this, so it's 2 times, and then divide both sides by 8 radical 26. You get df dt. Simplified version is this one. We rationalize the denominator, and we are done for this problem. Next problem. The volume of a spherical balloon is increasing at a rate of 6 cubic feet per second. How fast is the radius changing at the instant when the radius is 2 centimeters? So since it's spherical, we know the volume equation or formula is this: v equals 4/3 pi r cubed. So given is this, dv dt is also given, is increasing at 6 cubic feet per second, is dv dt. Goal to find the rate of change of radius. That means dr dt we are looking for. Take the derivative dv dt. So this one I say uppercase v or lowercase. So I'm using uppercase here. So 4/3 pi r cubed will be 3r squared, then dr dt. So all other values are given. You just plug there, simplify, and get your dr dt, which is 3/8 pi. Next example. Air is pumped into a spherical balloon at a rate of 6 cubic feet per second. How fast is the radius increasing after 3 minutes? Now this is the case here, 3 minutes. If you compare with the first equation, it has little difference. It's at 3 minutes time is given. So let's see how we do it. So given v is 4/3 pi r cubed. Rate of change of volume is dv dt, which is 6 given here, cubic foot per second. Should be cubic feet per second on here. Goal to find the rate of change of radius dr dt when t is 3 minutes. Assume that the volume of the balloon is 0 at time t equals 0. So then we can say 6 equals dv dt, which is this one here we have. Now dr dt you divide by this. Now the problem here is we need to find what is r. We don't know. That r we figure out from this 3 minutes. So after 3 minutes the volume is, the rate is 6 cubic feet per second. We need to convert this one to other variable. Let's see. You have, this is 3 minutes per feet. 3 minutes, we need to convert this into seconds. So 3 times 60 is here, and the rate of change is 6 per second. So that gives you the volume. To find r, now we plug this volume in this equation here. So you write r cubed equals 3v over 4 pi, and then we know our v is the volume, which is 3 times 60 times 6. Plug it here. At the end you simplify for r. R to the 3 is this. Now r cubed is this, so you need to find r, so it will be cube root of this. So in trying the next part, r will be cube root of that one. So this r value now we can plug here. You can use calculator to get a value there, or just put it direct, but don't round it. So we put all this, and at the end we simplify in our calculator, and we can get some answer.